We've put together this video to show what is required for condensates under British Standard 6798 and also some differences that could be in manufacturer's instructions. British Standard 6798 is a comprehensive standard for specification, selection, installation, inspection, commissioning, servicing and maintenance of a gas-fired boiler of a rated input not exceeding 70 kilowatt. So basically a domestic boiler. We have taken all the parts out of this relating to condensates to make it easier for you to understand. Also, we have also added some parts of the boiler manufacturing instructions that do supersede the British Standard 6798. And as you can see, on most of the boiler manufacturer's instructions, it does relate to British Standard 6798, and then it could have some differences. So it's always good to see the British standards and also the manufacturer's instructions. Also, not forgetting, in the manufacturer's instructions there's the benchmark, and it clearly states British Standard 6798 needs to be complied with along with the manufacturer's instructions. The installer will record on the benchmark what has been carried out for the condensate and what protection measures have been installed. So let's have a look at the parts that relate to condensates. The first part is referring to a 75mm trap, which in many cases the boiler manufacturers incorporated this into the boiler. The next part is the standards for all external condensates. The internal part of a condensate pipe shall be a minimum of 19mm ID, and outside will be a minimum of 30mm ID. And where a condensate pipe is taken through an unheated area, it should be classed as external. The next part is general requirements and standards for all external condensates. Part A states that where it does go through the wall, it needs to be increased to 30mm minimum ID, and the angle needs to be steeper than 2.5. Part B, keep external runs to a minimum, preferably less than 3 meters, taking the most direct route with no horizontal sections that can collect any water. Part C, keep all the fittings down to a minimum, cutting the birds off internally. This is really important to keep this water flowing and keeping the temperature as hot as we can to termination. Part D, to minimise wind chill on an open drain, get the termination below the grate level and above the water level. Also, covering any open parts of a drain will help to protect for wind chill. We have got some solutions for that. Part E, to improve drainage, cut the end at 45. I don't really think it's to improve drainage, more of to stop the ice forming on the end of a 45 because it can't cap. Part F, we must insulate any external pipe work as it comes out of the wall. This is to make sure we get a good seal around the insulation, and also making sure that you're using a good seal any joints or any 45s. And this must be waterproof and weatherproof insulation. Part G, advise the customer on the external condensate and in extreme weathers where to look where there could be risks, i.e. on the termination, the end of the pipe. Part H, as well as insulating the condensate, you could advise the customer about trace heating, making sure it's installed to the manufacturer's instructions. There's a note here stating that Classo insulation is not UV stable if it's not protected correctly. And we've also found that if it isn't sealed correctly and water is allowed to enter between the pipe and insulation, this will also deteriorate the insulation. Trying to protect and seal Classo insulation also has its problems, as it can't be carried out in certain temperatures or certain humidities. So basically in winter time, just can't be done. We are told we have to get an handle of at least 2.5 on the horizontal, or approximately 45mm per 1 metre. And again, the number of bends and 45s to be kept to a minimum to reduce the risk of condensate being trapped. This part is advising that on a gravity run there is no restrictions on the length, however it is recommended to keep it as short as possible. On a condensate pump, we should refer to the manufacturer's instructions for the length restrictions. On the condensate pipework, it should be supported a maximum spacing of 0.5 on the horizontal and 1 metre for the vertical. This is a part referring to septic tanks, treatment plants, cesspits, etc. Taking advice from the responsible person or the owner. You may have to fit a neutralizer or not be able to connect to this at all. This part is referring to connecting to cast iron soil stacks, stating to connect into the vertical or the shortest length as possible, and also take care when drilling as it's prone to shattering. If there is no drain available, then a purpose-made soakaway can be made. This is a diagram showing a soakaway. If you are taking the condensate pipe underground, this will still need to be protected and sealed correctly. Please check with your manufacturers as well about air brakes, as with the floodings that we've had over the past few years, it is recommended to put a air brake outside to protect the boiler from any areas that are prone to flooding. This is showing a condensate connected to an existing waste internally, i.e. sink, basin or bath, that is then taken to the outside drain. This must be insulated to the correct standards. This diagram shows a condensate taken to an external soil stack. The next diagram of an external condensate to a rainwater to a file drain combined drain, showing you insulated and also leaving an air gap. So let's recap on some of the parts in British Standard 6798. On the survey, can the condensate be installed internally? If it has to be external, then pipe internally as far as possible, then go outside. A minimum 30, which will be 32 minimum diameter external pipework. All external pipework must be insulated where it emerges from the building to go to termination and sealed correctly. If it goes to an open drain, terminate below the grate level and above the water level. If it is an open drain, protect from wind chill. See our solutions for wind chill. If it is an open drain, cut the end at 45. The owner shall be advised of the external condensate and shown how to examine it when there is extremes of cold weather. So looking at Class O lagging and the reasons why they're stating not to use it unless it's been protected and sealed correctly. First of all, it gets damaged really easy. If you look at the manufacturer's instructions, it must be painted twice, but that's going to cause a problem. If the temperature is too low, you can't do it, and the moisture is over 85% humidity, you can't use it. Then just the deterioration that we found is if you don't protect it properly, it just turns into a sponge. Then there's the other type of Class O, which is the self-sealed type, and this starts to come apart when it's really hot or when it's really cold, or it gets any moisture in it. And the big problem that we have is we can't let any moisture or water get inside this lagging or any other lagging, because then it'll just become a fridge and it's useless. These are one manufacturer's instructions for the paint and the adhesive, and as you can see in these photographs, if it is not protected correctly, it deteriorates with the UV, and also if water penetrates between the insulation and the pipe, it starts to deteriorate it inside, then failing and acting like a sponge. So just to cover, Condensate Pro covers all the British Standard 6798 regulations. Sealing with the bond and seal is correct. This then goes into the building with the pipe snug, and that seals up correctly. That seals into the wall, and then you take 1.25 inch, 32mm all the way through. So that covers all the regulations for British Standard 6798. So some differences we found in some of the manufacturer's instructions that aren't in the British standards. One would be insulating inside a cavity wall. Now obviously this doesn't need to be UV protected because it's inside the cavity, so you can use standard insulation for that. Some manufacturers are allowing us to use the 21.5 overflow, but the transition must be inside the fabric of the building, using a 21.5 to 32mm reducer. So other instructions that could be in the manufacturer's instructions states that we may have to insulate inside the cavity wall to protect it. If you just use some standard Tubulite 9mm wall thick and use the 52mm core all the way through, that then pushes through and seals to the pipe snug and then seals all the way through the building. We've come in with the insulation inside the property, and what we could have a problem is trying to seal around that. Talon do a cover, and that comes in all different colours, and that could be easily put round there and make a lovely seal. So some manufacturers are stating we can use a overflow pipe through the fabric of the building and then terminate it inside to 32mm. What you'd use then is a reducer, 21.5 to 32, and that will then go into the 32mm socket, making a perfect seal. What I've also done, a little tip, is if you take the burr off that stops the pipe and extend the pipe all the way through, and then that allows it to then go over the pipe, so then it allows the water to run faster and keep the heat and get to the bottom and terminate faster. Hope all that information helped. And if there's any questions, don't hesitate to contact us.